first we discuss what is the definition of differential equation. So obviously we know that what is the definition of equation. Now we discuss a differential equation. That means an equation involving derivative of one or more dependent variable with respect to a one or more independent variable is said to be a differential equation. So any equation which involve the differentiation with respect to one or more independent variable, one or more dependent variable, then the equation is said to be a differential equation. As for example, suppose if we write d cube y upon dx cube minus 2 dy by dx plus 4y is equal to 4 e raised to x. So this is the differential equation because d cube y by dx cube is the third order derivative, dy by dx is the first order derivative, y is a dependent variable and x is a independent variable. So now this is said to be a differential equation. But in equation 1, only one dependent variable y and only one independent variable x. Now equation 2, so d cube y by dx cube minus dy by dx whole square plus 4xy is equal to cos x. So again, y is a dependent variable, x is an independent variable. But in equation 3, here equation is a del t by del theta. This is the symbol of del, a partial derivative. So del t by del theta is equal to k del square t by del x square plus del square t by del y square plus del square t by del z square. So now the third equation, t is a dependent variable, but independent variable is a theta, x, y, z. So here 4 independent variable, only one dependent variable. So again, I repeat, a differential equation, that means an equation which involve the derivative of dependent variable with respect to an independent variable, where the independent variable is one or more and dependent variable is also one or more. Now there are mainly two parts of differential equation. The first part is ordinary differential equation and the another part is a partial differential equation. So what is the definition of ordinary differential equation? The short form is ODE. ODE. So ODE, that means a differential equation involving a derivative of dependent variable with respect to, the main word is only one, with respect to only one independent variable is said to be a ordinary differential equation. Equation 1 and 2 are an ordinary differential equation. So in a previous slide we discussed equation 1, 2, 3. But here equation 1 and 2, where y is a dependent variable and x is a independent, y is a dependent variable and x is a independent. So only one independent variable is there in equation 1 and 2. So we can say 1 and 2 are ordinary differential equation. So in a mainly ODE, that means the derivative of dependent variable with respect to only one independent variable. And the another form is a partial differential equation. So a differential equation involving a derivative of dependent variable with respect to more than one independent variable is said to be a partial differential equation. So here the main word is a more than one independent variable. So what is the difference between ordinary differential equation and partial differential equation? So in ordinary, here only one independent variable. In a partial, more than one independent variable. The short form is a partial differential equation. Short form is a PDE. So OD and PD. OD, that means only one independent variable, and PD, that means the derivative of dependent variable with respect to more than one independent variable, which is said to be a PDE. So in a previous slide we discussed equation number 3, where t is a dependent variable but theta, x, y, z all are independent variable, and here independent variable is more than one. Therefore equation 3 is PDE. So 1 and 2 is ODE and equation 3 is a PDE. So this is basic definition of ODE and PDE. Now, the order of a differential equation. So the order of a highest order derivative involving in a differential equation is called order of differential equation. Again I repeat, the order of a highest order derivative involving in a differential equation is called order of a differential equation. So suppose this example is given, d raised to 4y upon dx raised to 4 minus 4 dy by dx raised to 3 plus 4y is equal to 4 cos x. So in this ordinary differential equation, because this is the ordinary differential equation, in this chapter we discuss only the ODE. Okay, so in this equation the highest order derivative term is this, whose order is 4. So we can say the order of the differential equation is 4. So order, that means the highest order derivative order is the order of a whole differential equation. Now the definition of degree of a differential equation. So the degree of a differential equation is the degree of highest derivative which occur in it when the differential coefficient have been made free from radicals and fraction, if any. So the degree of a differential equation is the degree of highest derivative. As for example, suppose in this equation the highest order derivative is a d raised to 4y upon dx raised to 4, whose degree, that means the power, is 1. So therefore, the degree of this equation is 1. Now in the second equation, here equation is a d cube y upon dx cube raised to 2 plus d square y by dx square plus y is equal to 4e raised to x. So now in this equation, d cube y by dx cube, so highest order derivative is a 3. So order of this equation is a 3. And the power of highest order derivative, that means the degree of highest order derivative is 2. So 2 is the degree of equation. So again, I repeat, the order, that means the highest order derivative, and the power of the highest order derivative is said to be a degree of a differential equation. Now next, linear differential equation. So linear, that means a differential equation is said to be a linear if the dependent variable and every derivative of the equation occur in the first degree only, and they should not be multiplied together. A differential equation is said to be a linear if the dependent variable and every derivative of the equation occurs in a first degree only, and they should not be multiplied together. So suppose this equation is given. So why this equation is a non-linear? Because the degree of this term, derivative of this term, is a 2. So indirectly dy by dx into dy by dx. So multiply of the derivative. So this equation is a non-linear. And non-linear differential equation, that means a differential equation which is not a linear is called a non-linear differential equation. So here given that equation 1 is a linear, whereas equation 2 is a non-linear. So we discussed in the first slide. So this is the linear equation. Why this is the linear? Because this is the third order, but degree is 1. First order, degree is 1. The dependent variable, degree is 1. And in every term, no multiplication is there of the dependent variable. So therefore the equation 1 is a linear equation. But in equation 2, dy by dx into dy by dx, so second degree, so non-linear. So therefore we can say equation 1 is a linear, whereas equation 2 is a non-linear. Now here also we can say dy by dx 2 times. So product between two derivatives, so non-linear. Suppose dy by dx plus 4y square is cos x. So product between the dependent variable, here dependent variable is y. So given that y square, that means the degree of y is more than 1. So the equation is a non-linear. Now we discuss equation of a first order and first degree. So there are two standard form of a differential equation of a first order and first degree, namely dy by dx is equal to f of xy and m dx plus n dy is equal to 0, where m and n is the function of x and y. So main only two forms of a first order and first degree of a differential equation, first and second. Now we discuss a various method to solve such type of the equation. That means we discuss a solution of a first order and first degree differential equation, ordinary differential equation. So possible to classify them. First is a separable variable method. Second method is a homogeneous type of equation. Third is the exact equation. Fourth is a equation solved by the integrating factor. So there are different types of the method we discuss in the next lecture, and a different method which can be used for solving a first order and first degree method, first degree ordinary differential equation.